Hi everybody. Here I'm going to talk about fluids in rotating frames. This picture shows the second chapter of Fluid Mechanics by Monsoon, and here you can see there is an analytical solution for the shape of the interface. Well, I'm going to simulate this problem by ANSYS Fluent. Here I open the workbench. Instead of a cylinder, I want to model a cubic space. Any kind of geometry is possible. Here, um, Fluid Fluent. Put the block here. Right click on Geometry, Design Modeler. And create primitive box, and just uh, enter the dimensions. For example, for X dimension we have 50 centimeters, for Y we have 25 centimeters, and for Z we have 10 centimeters. Generate it with the view and just shift shift the cube for some values. For example, in X direction minus 25 centimeters, in Y no change, in Z direction minus 5 centimeters. Again generate, and here choose add frozen, generate another cube, create primitive box just like before, 50 centimeters, 25 and 10 centimeters. Here generate it, and just I want to put this cube on top of this one, so this should be minus 25, this should be 25 centimeters, and this one like before 5 centimeters, and here choose add frozen, generate. Well, you can see these two on top of each other. Select both these volumes and select form new part. Okay, let's go to the other step. Right click on mesh, edit, and for any computational fluid dynamics problem you need to divide the domain into small pieces, small volumes named grid or mesh. Generate by default. It is a little coarse. I want to refine the mesh. Here in sizing, maximum size is 1 centimeters, 1 centimeters. Okay, another time generate. Well, this one is much more better. And just right click on model and insert some name selections. Here press F2 for renaming, it's optional, and this is for example walls, the other one is water, and the third one is air. On walls, click in this field and select the surface, put your hand on control key and select all the sides. Okay, apply 10 faces. It is correct. And with the view, for water, select volume selection, the bottom volume, and for air, the top one. Okay, go back to workbench, right click, update to have a green check mark, and just let's save the project here, for example, anywhere you like, here in SRF with any name you like, and then right click and edit. I'm going to have a parallel simulation. You can use it, you can use a serial one. And here let me tell you what to do. We have gravity in y direction and minus 10 meters over square seconds, and nothing else here. In model multi-phase we have two phases, water and air, two phases. Okay, apply, and let's go to materials, fluid, air, and add the water liquid here. Copy, close, create and change, close, go back to multi-phase, phases tab. Primary phase is, for example, water, apply, and secondary phase is air, apply. Just close these, we do not want them. Go to cell zone condition in fluid, in air. We know that this volume is going to rotate about y-axis. This is the y-axis. Uh, we shift. We shifted the volume so that the y-axis is just in the middle of these sides. Okay. So frame motion must be activated. Rotation axis origin is okay. Rotation axis direction must be like this, and rotational velocity in radians per second. If you want other kinds of units, just come here, units, angular velocity, RPM, revolutions per minute. Well, I choose about 60 revolutions per minute, which means one revolution each second. Apply it and just do the same for water phase. Frame motion. This is 1, this is 0, and this is 60, just like before. Apply and close. Well, let's go. No need to change anything else here. Just come to initialization, and as you can see here, phase 2, which is air, is 0. Initialize, this means everywhere is water, because phase 2 is 0. We need to fill the air on the upper half. So this is the patch, phase 2 volume fraction for the upper half, which is air. This is 1, and patch it, close this. If you want to test you are right, go to graphics, contours, select density, and just select all the zones and display. Well, as you can see, everything is okay. The red part means higher density, as you can see in the legend here. 1000 kilograms per uh, cubic meters, and about 1 for air. This is air, this is water. Okay, just let's save the project and go to the other step. And by the way, go back to general. When we choose volume of fluid, this changes into transient, but we just need the final solution. So I again choose steady. Go to run calculation, and before that, let's have some pictures of the process. Solution animation new. For example, every 5 iterations, show me a picture in PNG and show me the contour. This is the contour, okay, this is okay. Display, close, okay. And here, select the number of iterations, for example, 200, and start. Well, as you can see, the interface is changing into a bowl shape. It goes up and down for some iterations, but as the process continues, the shape goes into a steady state. Well, right now, as you can see, the shape is not changing anymore, and so this is the final solution. Well, this problem was very easy. You can do lots of practical and complex real problems with this great CFD software, ANSYS Fluent. I wanted just to show how to do multi-phase um, rotating frame case. I wish it was useful to you. To the next beautiful scientific engineering CFD video, I say to you, be safe and goodbye.